Hello, Building Construction 2. This is Professor Snell. As promised, I am sharing a video about the climate data programs that I introduced yesterday. I decided to make a new video because the other one was not specific enough, and I want to cover some other things that are introductory just to how we're going to do this course. So I made some notes for myself. I'm going to follow these. This may not be completely efficient. I may have to pause it, so I apologize. The idea is just for you to scroll through and use it as you need. Um, so first off, so here we are at near the end of the slides that I presented yesterday, and Professor Cody added some slides late in the morning before, and so I didn't get the final version. So I need to go over the things he added with you. So this is basically the end of what I was talking to you about. He added, so I had this slide that was basically saying, trying to summarize what I'm expecting to see in the climate analyses, because I'd gone and given you this very detailed, well, maybe not that detailed, but more detailed than you needed to do this assignment lecture. And so I wanted to say, look, this is basic. Don't get stressed out about it. And then he added some more general comments about other assignments. So I want to go over those, and then we'll look at the precedents. I mean the program for the full semester, and that will lead into talking about the climate stuff. So um, I'll go over this again in class next week too. But you should go look at the slides again if you want to prepare, and in terms of get a feel for the semester, and see what he's put in here. So he's saying that each student will provide a separate portfolio of work. This is for the final project in portfolios, and he describes what we need for the projects. The precedent stuff we're doing now are the other climate information, and then what I want to point out here is that there's a fair amount of work here, right? And the last time I'm going to talk about this for the issues we had last semester with people feeling that whatever you felt, that it was too hard and I didn't give you enough specific information or etc. What I was doing is following a course book, and there is a course book that is general to our program that is supposed to be built upon every semester. Um, and it has all the stuff that I asked you to do last semester in it. I did not add those or create those assignments. Those were part of the course book. And I can't change that, so I can't simplify that. What I can do is more directly, first of all, just really try to communicate with you and have you talk to me. And I can try to give more specific examples or even say, let's just do exactly this and exactly that as much as I can for things that are repeatable. Um, but, and this is also the last time I'm going to mention this, one of the issues that occurred last semester, and it's just the way things sometimes go, is that the people in the section that were right across from me were following a completely different course book. So you didn't do a gallery. I don't think you did steel or even CLT. Um, you didn't have groups, and you didn't do any of the drawings that we had in our course book. And again, that I did not create, that I was following. So for example, when I took my section into the code, the reason I did that is because the course book said you need to make drawings with scaled members. And the only way I thought, well, that's going to come from the code. I mean, we're not structural engineers. I'm not going to go down that road. So I'm just going to point you to the code, show you where it is and how you can determine what the sizing of the members will be. What I'll do different this semester is we'll just decide what the sizing of the members are going to be, I think, together. So I'll add things like that. But again, my point is simply that I'm not creating the content. I'm just trying to help you generate it. I'm not creating the assignments or the scope. Okay, anyway, that's all we need to say about that. If you have any questions, please ask me. Okay, now let's get into the content. This is the program for this semester's series of projects. Remember, what we're doing is we're going to be doing the same project all semester, just repeating it as we did last semester in most of the sections of Building Construction 1. And the difference here is it's a larger scale, right? So we've got a much larger gallery area, some office space that is a larger office than we used last semester, parking, an entry area, and two building cores. In other words, that's going to be for stairs, maybe elevator. We'll see exactly, but that's the service core. That we could also say that's where some HVAC is going to be. So very general, but we're starting with this and we're keeping it for the entire semester. So this is an addition that I did not have in class, which should answer some questions. One other thing I didn't mention, and we'll talk about this in detail, and I'll help everybody with it, is this statement here at the end. There's part of the final exam is going to be that everybody needs to turn in section drawings of each of the projects. And so you have to have a different section for each group member. So that's, in other words, we are going to have groups and you're going to split up the work and trade off, but then you also each have to make your own section. So again, I'm going to help you. It'll be fine. Hopefully it'll be fun, but there is some work here and you need to keep up. Okay, anyway, and then we did the program, like I said. So the first thing we need, though, is our groups. So let's go to Canvas, and I'm going to remind you. So I'm going to set up Canvas to where this is where I share things with you. I'll try to organize it as best I can. We have a syllabus here now. This is still the draft. I'll put the final in before next class. Resources, I'll put general information in, like the passive modeling tool document that we talked about in class. We'll go over that in a minute. I also decided just to go ahead and put that in the first week again, just to make it really clear. This is where I'll put my slides. Starting next week, I think I'm just going to use Professor Cody's slides, because that way then we know we're talking about the same things. And if there's any changes at the last minute, then I'll know about them. And you will see, if I guess I'll post his slides for last week here also. They're very similar. I just, I focused on, well, they're similar. But from now on, I'll try to make them exactly the same. Okay, the first thing in here that let's talk about is a team sign-up sheet. So I'm going to click on that. Just so in case you haven't used this before, in Canvas, like, yeah, you can interact with this right now, but it's better just to go up here to this link and open whatever it is, the link in a browser. So what I have here is a list of everyone in the class. So on this people sheet is everyone in the class. And then in groups, I want you to fill out or identify the teams here. So the reason I did it this way is in case you're not in a team, you have people's names and their, this is just their username. If you add at NYIT.edu, you get their email address. And let's create the groups here with member names and emails. Then what I've done to simplify this assignment is I've assigned you each group a climate data file. So we'll go over this in a minute, but you can click on this and the climate data file will be there, and you can download it and use it in the two programs that we've introduced. All right, so that's the first thing you need to do is generate your groups and let me know who they are. A question came up in class as to, well, how do we organize this? It's not a studio, and you're not together all the time. How can we make this work? So I think there are a number of options. So let me just go through a couple of them. Option one could be that you divide the work as follows. First, you have a design direction, the decision on the formal approach to the problem with this, either for assignment one, for example, how we're going to interact with the climate, and then moving forward, how you're going to change the form maybe for each different building assembly we use, if you want to do that. Could be that you do all that together and maybe do that in class. I'm definitely going to try to have studio type time in class every week. And keep me honest on that. If I'm not doing it, just say we need to do a lesson a week, and I need to give you more time together. So you could do that together, and then one person could do the model, and then you could split the plans and sections that are defined in the assignment between each the two other people, and maybe one person would do 2D or horizontal sections, plans, and the other would do sections, or maybe you'd split them up. That'd be one way you could do it. Another way you could do it would be to say, okay, our three roles. The first role is going to be there's the design direction is going to be one person, and they basically on that iteration. So if we're doing steel, they're the project manager, and they're the main designer, the lead designer, and they are going to determine the form and make the technical decisions, and then assign that to the other two group members. And so one of the group members in that case would do the Rhino model, and the other would do all the plans and sections, and then the design director would then do all the layout. And the point here is that if you did either of those two approaches, then you would want to switch those roles each time because one might be easier than the other. They should all be the same difficulty in each iteration. So in other words, the designer would have the same difficulty, I think, in any of these or in the model maker. But you want to separate them so that you're all getting these skills and also so that nobody's working more than anybody else. You're graded individually, so you sign what you do on each assignment you turn in, and I grade that individually. A third option would be to discuss this with your group and decide yourselves. And that's completely okay with me for you to do that, clearly. So, but that's important. You need to decide together how you're going to organize this. Since you're creating your own groups, I'm hoping that you can agree to work together and find a way of doing that. If you have any problems, you can, of course, talk to me. All right, so the first thing you want to do is fill this out, get your groups going, and decide how you're going to work together. Now, let's talk about assignment one. Professor Cody has supplied us with examples from last year, and I've placed those here, assignment one examples from last year. So you have access to this. I'm going to open it now so that we can just discuss it briefly. Completely different climate, and I'm not going to go through these in detail. We can talk about some of these specifically in class if you like, but just to give you a feel for it. So there's a site map. Now, what I said in class was that you could just choose a blank site, and I think that's okay. I think it'd be better to pick a site that has some context so that you get more experience understanding how the sun and wind are affected. Maybe not the wind so much, but definitely the sun. The wind is affected by the context, but you won't be able to see that. You just will have your raw data. But anyway, so they have determined the basic parameters of the site, and then this group's made clear decisions on how they would respond in winter and summer, spring and fall, the two equinoxes. And then they showed us some data from a couple of programs. One of these is Climate Consultant. The other is that link that is supplied in the slide in, let's see, let me go to that. There is in the assignment, which was defined clearly in a slide, there is this GEISMA that I'm saying I would just use Climate Studio, but you can use GEISMA too if you want to. And that's where I'm just pointing that out because that's where these images are coming from, these GEISMA images. These here. Anyway, what I would absolutely want you to do is write some short descriptions here. Of course, you're presenting, so maybe you would just present them. But I think you want these to stand alone also as things that somebody else can look at. So say what these graphics mean. You never want to share graphics that you don't know what they mean. And then they've gone and they've created some form that accomplishes the goals that they set up here, right? And by looking at the sun in the different seasons and the wind. And they've taken it, they're showing us the program more clearly, and then they've done some more detailed axons showing us how these specific strategies are being applied. And this would be still all in the first 2-week assignment. So there's some stuff here, but this is just surfaces. There's no you're not drawing anything to be built, or there's no sections or plans or anything. And you could slide through these and sort of see different ways people did it. There's different strengths and weaknesses here, but this is the basic idea for the first 2-week assignment. And then we'll take these designs. You'll choose one or keep iterating them, and then use those to do your iterations using the different types of material assemblies we're going to talk about. Okay, so that's the idea. So how are we going to how do we want to approach this? Let's go through that step by step. First, let's talk about how we will access the climate data. So I'm going to go through each of these programs that I'm suggesting you use and show you how you download them and how you work with them. So again, this video is going to be a little bit long, so you should be scrolling through it. If you are interested in this, go to the next thing. So let's go back to Canvas, go to Modules, and we have that Passive Modeling Tools page. So I'm going to click on that and open it. So let's deal with Climate Consultant first. We go to the download link if you haven't already done it. You pick the version that hopefully you're not on a Mac because you're going to have trouble and you won't be able to use Climate Studio if you are. But for example, I have a 64-bit PC, so I'm going to download that version of the software and then um, run it so that it installs. Simple as that. Then, so now I'm going to open it. So here's Climate Studio I'm sorry, Climate Consultant when I opened it. The first two pages are just information that you may want to read, telling you about the program, how to use it, etc. I'm skipping those two because I just want to go directly to um, the page where we're going to actually access our climate data. So if I go back to, let's see, where would that be? My team sheet, and let's say I'm in group one. I'm going to download this climate file, download it here. So now it's in my downloads folder. I would want to move that somewhere to where I know where it is. I'm not going to worry about it right now. I have it somewhere else. But so now I have this climate data file, and I can come back to Climate Consultant and start a new project. I'm going to use imperial units, not metric. That's a good thing to remember. Let's all try to do that. And I'm going to open an existing EPW weather file. EPW is just a type of file. It's a spreadsheet that has columns that are always, column two is always going to be whatever it is. And so people can use this data for different different pieces of software, for example, that they write, and they'll know what data they're bringing in, what it's for. So that's just simply what EPW is. So if I open existing, I'm going to scroll to um, that file I just downloaded, which was the North Las Vegas, I believe, whatever. It was in one of the Las Vegas, and I open it, and here it is. Now we're in Climate Consultant. We have the data in here, and we can access our charts. Let's leave that for now because now we have all these charts we can look at. I'm going to tell you exactly the charts I think you should use for this assignment and what they mean. We talked about it, but I'll give it to you again in a video so you can refer to it. Um, Now let's go to Climate Consultant. I'm sorry, Climate Studio in Rhino. We'll talk about this little context model I made in a minute. Actually, so let's go back to the passive modeling tools page. Um, what you want to do is, first of all, you can just download the file directly from here. If it doesn't work, I said, note if the hyperlink doesn't work, cut and paste it into a browser. All you're doing there is accessing the file. If you open the file and run it, because it's an installation file, when you open Rhino again, Climate Studio should appear. Okay. To get more information on that, go to this installation guidelines page, and this is actually a page. Let's just go back to. This is just a page from that passive modeling tools, or a link from that passive modeling tools page. So if I go here, um, this is just a website they have that has all their help files. So this is where the installation information is, but also if you're trying to figure out how to use a tool in Climate Studio, this is where you would go, climatestudiodocs.com. Okay, so if we that's all I can tell you about how to how to access the file. If you have any problems, you can let me know. Um, so I'm going to go into Rhino, and the way it works is, and it tells you that in the installation information, is that first of all, I'll show you how Climate Studio is going to show up, but it's not going to ask you for the key until you run a simulation. So you won't need this key until it asks you for it. And just remember that's where it is if and when. I'm not sure if it even asks you for it when you're doing these simple things we're doing today. So I don't know. You'll see. But when you open up Rhino after you've downloaded Climate Studio, remember yesterday somebody had a problem. Sometimes you have to close it all down and open it up again. Just try. I mean, try a few of the obvious things, which we always do. Reboot your computer, open and close the file. But you should have a tab up here, Climate Studio. So if I'm over here in Page Tools, or you don't have Page Tools. So I'm in Seaplanes. I open up Climate Studio, and here are my tools over here. But there's also a Climate Studio Workflows tab that should show up, and that's the way I typically use it. You don't have to. You can click through these guys over here if you want to, but because this is where, once you get into this more, all of your simulations are here in a drop-down menu, and then your results show here in a different tab. I'm not going to have any results. We're not going to talk about that right now, but that's how this is set up. So all I'm trying to show you now, though, is if we're in the CS Workflow tab, or if I clicked on, this, the sun over here, and these little drop downs, I can see there's an Earth tab. Click on the Earth tab, and that's where I get my climate data from. So if I click on the folder, I can go to my downloads, find that North Las Vegas, and open it and put it in there. I'm not going to do that. Well, I will, just so you see it. Now it's North Las Vegas. I'm going to switch back to New York because I don't want to just do the exact thing you're going to do. So I've got a different climate file. It's the same thing. So now we have the same climate file theoretically in both Climate Consultant and Climate Studio, right? That means we have our tools. So let's go step by step for how we at least get this project started, the climate assessment portion, or the assignment one. Okay, so first let's create a climate summary. We need to look at the climate just by itself without any concept of buildings first. And what I showed you in class, what I would do is create a spreadsheet like this, or it could be a table in Word, and just you can copy this line for line, not the inputs obviously here, but this would be the basic information that I would want to have about a climate. There's maybe other things. And I'm going to show you an easy place to get it here in a second. You could also create a page like I did where you maybe did use New York or something and then had your climate in two columns, because if you use a New York data set that you download and get this basic information from, then you could start understanding yourself better the climate we're designing in, because you understand the New York climate, and it would be a good way to probably go back and forth. Not a requirement, you could just do this, but I want to see this or something like this in your assignment one. Okay, where do we get this information? Well, the easiest place to get most of it is right here in Climate Studio. Because if I go back to my Earth, here it is. All of it's here. That's basically exactly what that, I don't know if it's exactly, I'm not sure if I copied this directly, but it's all this basic. Yeah, like I don't have the Koppen. I'm just using the ASHRAE climate, I think. Maybe I did put the Koppen in. Anyway. And you don't have to do this exactly, but why not? You're just beginners. Now, remember what I said yesterday, though, or in class, is the one thing I do not want you to use here are these heating degree day and cooling degree day numbers. I think they're wrong. I don't understand. I need to talk to the Climate Studio people, but I can show you where to get those, right? So we're creating this chart as a starting point for our climate. And I have in the module, I've given you a link to this US government site that I showed you yesterday. So I'm going to click on that and open it. Now, there's all these really cool US government resources, but a lot of them, it's like engineers and other eggheads that are making them, and they're not maybe thinking about the user that much. So this one's, first of all, it's really hard to find it. Like, they have so much stuff going on, and this is a great page, but you kind of have to get directly to it. So just use go directly to it from the link that I'm giving you, and then I would bookmark this just so you can use it for other times. The way this works is you have to be on this map, and then you want to get close to where you're going to, the climate data you're looking for, and click. So I'm going to click here on Long Island. And now this dialog opens up, this page opens up, and I can go through, and there's a bunch of different uh, climate data sets in the area, right? So, but I think we were at Kennedy just now, or LaGuardia, one of those two. So I click on that, and I want to go to the monthly summarized data. So for example here, this would be a good place too to get, I don't think that in Climate Studio they have the annual precipitation, which is a good thing to have. So if I come on monthly summarized data, precipitation, go, I get this chart that has, and I can actually, I could copy this into Excel if I wanted to have all the data, but I'll just come down here to this is the mean, the average. And so for whatever set of years this is, the average is about 44 inches. So that's what I could put in to that variable. It's really interesting when you to have these basic bits of information, because when you start looking at a climate that has 44 inches and you compare it to one that has 4, you understand why there might be a different way to approach building the building. And without that, you wouldn't really know. A lot of times climates are very surprising. Like, for example, that a lot of times in the desert, we still have a very high amount of heating load, amount of times that we need to be heating. Um, okay, but the main thing I want to do here is go to the heating degree day and cooling degree day inputs. And so these are or data sets. So heating degree day, HDD, base 65, that's a 65-degree set point. That's the temperature we want inside the building. And remember what I said with this, that the heating degree day is simply, we say, okay, the temperature I want inside the building is 65 degrees Fahrenheit. Any day where the average temperature is less than that is going to be a heating degree day. Or it's going to, well, we're going to do the following. We'll take that day, take the average temperature on the day, so the 24 hours for that day, and let's say it was 45 degrees. Then the heating degree days for that day would be 20, because it'd be 65 minus 40. You don't have to calculate that. I'm trying to explain how we get the number. Then we add all those up, and that's the total heating degree days for the year. That's the times we need to be heating. So I'm going to click on this, scroll down again, my mean, my average. So in the New York area, around 4,500. These are not going to be exact, and they really fluctuate. If you look at the different years here, we've got some as low as 3,890, 5,000. I think this might even, yeah. Um, and so this is where you get that number. And then we would do the same thing for cooling degree days. And we see it's much lower, 1145. And you'll remember that, I'm going to go look at my sample again that I showed you. Remember how just in New York, these 3 sites in New York, how much this fluctuated. 4350 for heating degree days for New York City, 63 for Albany, and 80, almost 9,000 for the Adirondack. So this is really important to know, and it's surprising how much it changes based on these are pretty close. These sites are pretty close together. Okay, so now we've got, oops, wrong. Where was I? I was here. To get back to the map, sometimes if you were like, okay, I want to go to find a different site, I would just go back and click that's why I would have it saved as in my browser, or go back to here and open it up again. Because like I say, it's sometimes hard to get back to it. You could just back up your browser and get there too. Okay, now we have our summary data set. What do we want to do with this data? we want to get a basic idea of how we want our building to interact with the site resources, with the sun and the wind and water potentially. I'd say potentially just because if you just want to do sun and wind, that's okay. I would look at water also, but we can go step by step here. That's fine. Okay, so let's just go through this, and you could expand upon this and get more into it, which I hope you will over time, but let's just be real clear as to what would be fine for this assignment. Um, let's just go back to Climate Consultant. Remember, we have all these charts. By the way, I want to remind us that when we get to the psychrometric chart, we need to set the comfort model, and mine is set on the California Energy Code. You can set it on whatever you want. It just changes. Let me just show you that real quick. The psychrometric chart. I'm actually going to turn this off just so it's straight. Oops, can't do that. I'm going to turn all these off. So we just have the comfort zone. Kind of getting ahead of myself here, but so for the California comfort zone, it's this is the shape of it, and this is just basically saying everything in blue is the 5.5% of the year in North Las Vegas where you're in comfort without doing anything. Just outside, you could be standing there, you'd be comfortable. If I change this to a different comfort model like ASHRAE, you'll see that then we have a different comfort zone. That's the only thing that's different. The blue area is different. Right, I'm actually going to change my my data set here because I don't want to use the same one you're using. So let me see if I have something. I probably have. Yeah, we'll just use Kennedy. Okay. So the first thing I want to do then is let's figure out. So we already have. If I'm over here in New York City, LaGuardia, it's close enough for this. Um, well, actually, I am going to leave it the same because this is just conceptual. I already know that I'm in the mix 4A climate zone. Let me just be super thorough here and go back in the slides and show you what I'm talking about there. Remember we had this colored chart. So we're in 4A because in Long Island, 4 is the yellow, A is anything from this line over. Long Island's 4A, then part of New York is 5A, and then the rest of it's 6A. Okay, so if I go back to Climate Consultant, I've got and I'm going to put this up next to it. I know in 4A, I've got some basic information about average temperatures, solar radiation. I'm not going to talk about that right now. Precipitation, wow, a lot of water, coldest month, etc. But what I don't really know is when are these heating degree days and cooling degree days happening? Because I need to hone in on that so I can decide, do I want to adjust the form of my building at different times of year? Do I want to have overhangs, etc.? So the first chart I would use from here is the temperature range chart because it tells us the gray is the comfort zone, and then the line here is the average temperature, the mean temperature. Well, you can just read these, and then average high and low are the yellow, and the design high and low are the green. Remember, the design high is the highest or the lowest temperature, and that's what we use for worst case scenario to design HVAC systems. Don't need to worry about that in this semester at all. Okay, so what I'm seeing here is, well, definitely January, February, March are heating seasons because there's no temperature ever that gets into the comfort zone. November, December also. I'm thinking definitely October. I mean, all these that have the averages are probably heating seasons. But this is subjective. You can interpret this however you want as long as it makes sense. But from this, and we would say we're going to be thinking about heating in these months and cooling in these months. Okay, that's the first thing. But then we need one other chart, I think, from here that goes along with this, which is the sky coverage, the cloud cover range, sky cover range, you're calling it, this cloud cover. What we're saying here is that the mean for each month, the average, is this uh, break in the bar right here, and then you have the highest and the lowest, so pretty straightforward. What you want to do then in your climate is compare this to um, the to this temperature range chart. And so I did that in the slides. So let me go back and see if I can find that kind of quickly here. It's down here. Again, I know this is kind of long, but I think it's the best way I can do this. So if I'm looking at these side by side, and this is how I would have it in my analysis, for assignment one, is I can start saying, okay, well, January, February are really cold, and December, those 3 months, January, February, December, they all have almost exactly the same shade profile. It's about 60% average, but there's definitely some times when it's really low and times when it's really cloudy. So I would decide based on this if I think do I want to try to bring the sun in the winter into the building so I can get some heat from it? Do I think it's not worth it because it's too cloudy? Again, you're not experts at this, but that you would then use this. And how are you going to make these determinations? Well, I think you should look at the precedents. Maybe the precedents I had, they're all large buildings, so they maybe aren't that helpful for this. Professor Cody had some precedents in the slides that I'm going to share that he posted. And then you can look them up yourself, precedents for your area where you're designing. And to start getting an idea of, well, how do we deal with the sun and wind in this particular situation? Or you can use your common sense. If you want to have heat, let the sun in the winter. If you don't want to have heat, block it. If it's really windy in the winter, you should probably block that wind. If it's you got a nice breeze coming in the summer when you need cooling, then maybe have ways to either enjoy it outside with an outdoor space or bring it into the building. Simple as that, right? At this level. Okay, so I'm saying that for climate consultant, you should use the temperature range chart and the sky cover chart as a minimum. Then I would also go to the psychrometric chart, partly because it's listed in the assignment. So that's the other thing I would do is just go to the assignment and make sure that you're doing everything that's listed in that slide, which is right here, right? So there's a bunch of stuff that you're supposed to, and these are all things that I mentioned. That some of this is just in that summary table. We're going to do sun path diagrams in Climate Studio. The passive strategies comes from the psychrometric chart. So this is what we're talking about right now, these two things. So first of all, I'm going to, the psychrometric chart, if we turn off this display design strategies, it's just a bunch of, it's useless. Let me put it that way. I'm going to turn it back on and turn off all my strategies, except for the comfort zone. Can't turn off the comfort zone because that means that just the temperature and the conditions outside are comfortable for this many hours, 6.7% of the time. What is this chart? What are the axes? We have the dry bulb temperature, which is the sensible temperature or the thermometer temperature. You'll start seeing, this is why I'm showing you why I did that lecture at the beginning, the first week, because there's a lot of stuff in here that you need even at a basic level that you may not have come across before. Right here, why do we have 1% above and below? That's because of the design temperature that I talked briefly about. If you were to look at the illumination chart, you would start having, we didn't even talk about lux, or foot candles, so we'd have to talk about that if you wanted to understand it, or you can just think of it relatively. Anyway, there's a bunch of different, there's all these metrics that you need to start understanding in order to deal with climate. Anyway, the psychrometric chart, we have dry bulb temperature, which is thermometer temperature in the x-axis, and absolute humidity in the y-axis. Then these curved lines are relative humidity. So we're just basically plotting dry bulb temperature, the temperature on the thermometer versus relative humidity. The higher up we go with these lines, the more water is in the air, the less comfortable it is for us, especially in the summer. Um, so we need to look at both temperature and humidity to try to get these red dots to be green dots. And how do we do that? Well, we just start looking at these passive strategies. So as I said in class, you can really look at this Climate Consultant as a little book on climate and how to interact with it passively, in other words, with just building form. So I can just start clicking on these different strategies to see how well they'll help me with my comfort. And it's kind of a little game. So if sun shading, I'm being told I can get about 12% of these red dots into the blue dots. You can't really, what happens with this, when there's an arrow like this, it's just some of these red dots are switching over to blue dots, but it's sometimes hard to tell because they're spread out. Um, but you can just click through these and decide, well, maybe high thermal mass is only 2.6%. Maybe that's not worth thinking about. Um, but if I go to, for example, internal heat gain is a huge effect. And that's just, we can talk about it more, but that's just the heat of people's bodies and equipment. And so that's a kind of a given. So probably I would always select that. It's going to be different for different kinds of buildings, but definitely for the building you're designing, it would be kind of large because it's a pretty big building. And well, since it's a gallery, I don't know how many people are going to be in there all the time, but there'll be equipment. Um, and we could try natural ventilation. We get 12% there. So we can look at these different, this is one way to learn about these strategies, because then we can go to help and it will just, well, that's just describing the chart itself. But if I go to charts and design guidelines, um, I can find whatever design guideline interests me, click on it, and there's this little description of it here. That's one way to look it up or to learn about it. Um, nice graphics. They're pretty simple though, so you could also just do some research yourself. And if you're interested in one of these passive strategies, then you can do a little research and decide if you want to incorporate them. And we can talk about them if you ask me. I don't want to get too far into this. This is really for environmental systems, but it's in the course book for this semester, and we're doing a short 2-week assignment, so we can go wherever you want to with it. But I'm telling you what the basic minimum is. That you want to look at this, have a psychrometric chart, and I would, even if you're like, okay, I'm just going to pick these sort of randomly, looking for large numbers, and go, okay, that's, none of this rest of the stuff is big enough to worry about. Um, and then I'm going to say, okay, from here, I'm going to use mechanical systems. So here's the basic point. I've gotten to 45% comfort without any mechanical systems. If I add cooling and heating at the bottom, I get about to 100%. Often it's 100. I'm not sure if this is because um, I don't know, but I honestly don't know. I think it could be because there's some. Um, no, it's not because of the existing comfort zone. Maybe I don't know. So let's just not worry about it. It'll get close if you have, or you could try to come in here and fill some more in, right? Um, anyway, the point is we want to get as far as we can with passive approaches because these are the ones that would influence our form. And so this could help you determine some strategies that you could then list, like this team did in in their assignment one, right? So that's kind of the idea behind this. That is all I would do with Climate Consultant. So get the temperature range and cloud cover and the psychrometric chart. Now, you could do others. I'm just saying that I would expect to see these things. And it would be great if by next week you guys at least had these strategies thought through a little bit so we could talk about them in class, or we'll just do it in class, from scratch if we need to. Okay, next. Okay, now let's look at Climate Studio and see what we should do with it. Now, if you don't have Climate Studio working, and that's okay, you can use that Geisma app that is in the instructions for the assignment. This is since you're already using Rhino anyway, I think it's a really great thing just to spend the time to get this working. It's pretty simple once you get it going, and I think you'll use it. But and I'll help you if you need to. So here I am in Rhino. Uh, I've brought in, here's the climate data we were looking at because I'm at Kennedy International. I'm gonna click on the sun, And what we're going to do is we're going to look at how to study the path of the sun across the site, and look at wind data and talk a little bit about how we would iterate form. First thing that I want to do is show you, so um, this is the site that I'm using. It's So I just basically, there's another studio using this, so I just thought I would use it because anyway, here it is. And then I just built these context buildings. The site is this open area here, and I built the context buildings just as pull-ups. I actually did it in SketchUp. It's just as easy to do it in Rhino. Um, and one point here is don't make a giant site. Just make the site big enough so that the sun and wind and water that's going to affect your building will be clear or will be visible. And so that's basically what this site is here. I I have roads too that I'm not going to turn on for this for a reason that I'll just we can talk about some other time. And I actually did do a topo. Um, I'm not going to use it for this because I just think it's going to be simpler to use a flat site. So I'm going to turn off the topo. Um, and I may turn it back on for the shading. I'll leave it on for right now, just so you know that that's there. The reasons, so these buildings are actually sitting up on, they're not on the flat surface, that if I turn that off. Anyway, not to confuse you, I'm just saying I have a simple site here in Rhino that I made a context site. Now I'm going to come to the sun and turn on 3D sun path and shadows. And this is what it should look like for you, or something like this. I made these buildings a specific color because I think it's better when they're darker. If yours are white, you're not going to probably see the shadows very well, so you may have to play with this a little bit. You can position this sun. So if I go here and I set position, I can move it wherever I want. So set position again. I do want to set it right about where it was. And I can also change the size of it just by changing the radius right here. So I'm going to make it, well, that's actually a pretty good size for this. I could make it larger, but let me go 450. But then I'll come back to 400 because I think, well, 450 seems fine. And then now what do I do with this? Well, I can very easily, first of all, there's these presets here. So I can go through the solstices and the equinoxes. So I can go to summer solstice and go to 9 a.m., 12 noon, 3 p.m. and see how the sun is changing. I can do that from the top view. By the way, what I did is I just changed it to CSS shadows. That's the default for in preview mode. When you have the sun turned on, it will go to that CSS shadows. That is just the Climate Studio shadow setting, for this. So I would set it on that. But so if we're looking at June and June 21st, the summer solstice, 9 a.m., noon, and 3 p.m. And then I go to winter solstice, 9 a.m., noon, and 3 p.m. We see a huge difference. And we also see how this can be effective. And so if we done an equinox and did 9, 12, 3, we basically would have 9 images that covered the passage of the sun through the year in the easiest way possible. What do we do with this data? Well, if we're talking about building on a site right here, right, then we want to know how the sun's moving across the site. And we can do that. We could say, I want to know at noon or so, and just move it through the entire year and think about different things. I can be thinking, this is where I would say, okay, what's my heating season? I've already figured that out. So where is the sun at different points in the heating season? When would the sun go down, or when would I get shaded? Do I want to try to encourage the sun to come in or not? What about when it's hot outside? Is there going to be, do I want to, what can I learn about the solar path? Are there times that I would like to keep the sun out? And if so, how would I do that with where I face the building? Do I put it close to another building? If I, change the form of it, do I want to put my a certain portion of my program to where it's in the sun and another where it's not? Do I want to have the east and west side opaque so that they're blocking the sun, but then the south is open to the sun? Lots of different things you could think about here. But first, let's just look at the the technical side of it. So, very easy to do sun studies in Climate Studio. We can change the view. We can also at any point remember, let's keep things in IP. Now we're in this looking at this chart down here is the same thing. If I'm see as I'm moving things and you're looking at the model, if you look at this chart here too, it's also moving. And I can print this for any specific chart position I want. So I could bring these into my analysis also. Okay, that's the sun study that I'm expecting. Let me just show you that. I'm going to click through. We're going to do wind here, but then you also have, these are just the tabs that are in this site analysis set of simulations in the workflow. We have wind. We have that chart that I say I really like that has the diurnal temperature and wet bulb and all the horizontal radiation. We have a psychrometric chart, which isn't as good, and we have another chart that you can change different inputs and see the results. But let's just focus on the wind right now. If I come to, again, back to my top view, I'm going to turn my wind on. And I'm going to go ahead and turn the sun off. You could leave it on, but I'm going to turn it off, especially to be clear. Definitely want to change the size now of my, one reason I might leave this on is if I wanted to keep this this view type. But I definitely want to change my my radii. So I'm going to go, let's say something smaller like 10 for the internal radius, and for the outer radius, I'm going to go 400. So you can play around with that, those settings, and that's just right here in the inner radius and outer radius. At any point, we can, again, print this, right? So that's how I'm getting my winter and summer. And this is the main thing we're doing here is trying to figure out what the, so whatever my heating season is, let's say I'm going to, and by the way, these little scrolls can overlap, so you can go either direction. So if I want to go from, if I'm doing the summer, probably gonna, well, I'm sorry, if I'm doing the winter, I'm probably gonna say I'm gonna start my winter in beginning of November, maybe in this climate, whatever, and go to somewhere in February, March, April, whatever I want to do. You have to turn it on and off to get it to update in the model. You can also set the position of this same way, and you can move it as an, you can, well, I won't even get into that. But so this is a really nice graphic, I think, in the model window, and then we can also print out at any point, like I said before. And we can then get a screenshot for summer, for heating and cooling seasons. And we'll see that they're pretty different. There's already slides of this, and I just quickly threw one out there. Pretty different, right? So we're going to use that to determine, make the decision as to how we want the form of our building to be interacting with wind. And that's all from Climate Studio. So that's two things in Climate Studio, the sun study and the wind. Then also in Climate Studio, we can start to look at, you're going to be modeling this here anyway, so you can start to iterate. So if I'm going to turn actually on my contours right now, and probably I'll turn off the wind. If I then turn my sun on and I build a building, I start to have a building, I can experiment with how the site is shading my form and decide if I want to move it around, if I want to add an overhang that's going to shade at certain times of year but not at others. So you can, if you're organized. So, like, by the way, it's really good to have your layers in folders. So I can turn the site off if I want. Just have my building on. I can turn off my project. Just have the site on, and I can have multiple overhangs on different layers here in multiple buildings. So because you're gonna need to have two different. The assignment says to have two different forms that are responding to the climate. All right, those are the skills I expect you to, or the yeah, skills and data I expect you to incorporate into um, the assignment one. What would you do next to do that? So I've already said it, but let's just repeat. Using all this information, you want to decide how and play around in your model with ways that you can adjust the form and your program, how your program's laid out to interact with these environmental factors. Remember that there's examples from last year that you can look at. You can look at the precedents that Professor Cody and I showed you, and you can do some research yourself for your climate. That's a smart thing to do, and you could bring those precedents into your report if you like. I think that's a good idea. You could also really use your common sense, and what I really want to get across to you guys, let's try to have fun with this. It's not a huge deal. Um, but you need to start thinking about these things. So use your common sense. Like, do I want what I want if I'm standing in this building and it was this time of year and the sun's out? Do I want to have direct sun coming in? Do I want to? Can I lower the requirements of my heating system if I bring some sun in at this time at this time of the year, or vice versa for cooling? Do I want to block it? Really simple things like that. Um, and all I'm asking is that you spend some time. Please at least come in. Well, I'm not even going to say. Just get your group set up. See if you can get some stuff done. I'll take you at face value wherever you are, and we will work on it in class some next week. We also have to talk some about steel, I believe, but I'll make sure we have time to, in a studio-like setting, work on this. Okay, so that's my attempt to make this as clear as I can. It's kind of a long video. One other thing I want to do. Here are the notes that I used. So this is sort of a summary then of what I'm saying that you would probably want to have in your final your assignment one, right? As a minimum, and a map to how to get there. So I'll just scroll through this slowly so you can see the whole thing, and you can use this as a template if you like. All right, that is it. Let me know if there's any questions. I will see you next week.